I'm Jordan Brandt, co-founder and CEO at Inpher. So you got the dumb guy. Like I said, Maria wasn't able to make it. So you could ask me stuff about applications, real-world use cases, but no math, please. I'm also a board member at the MPC Alliance, and I think, in hindsight, thank you, Damien, for your talk wherever you are. I see why you guys accepted, these topics on privacy budgets, because we look at it in very different ways. Like at the MPC Alliance, we're focused on encryption and use, and so people are thinking about input privacy. They don't think a lot about output privacy. So I'm curious here, how many of you have developed, deployed, or used DP in your products or services? So maybe a third, a quarter. How many of you have used encryption and use, FHE, MPC, any of that? Probably many fewer, let's say. So we're approaching this as a company that has developed encryption and use technologies, and getting questions about output privacy and how do we quantify it. And so I'll talk a little bit about what I mean by hybrid PETs and input versus output privacy, which I think this audience knows pretty well, and then how we're viewing privacy budget in the context of using hybrid PETs workflows. So looking at PETs, generally speaking, FHE, MPC, FL, DP, et cetera, the ability to compute any arbitrary function without revealing the input data. But obviously, the output reveals something about the input. Now, we're looking at this at use cases that require high precision. That's really where we've shined and our product has matured. I think everyone probably knows the satellite collision if you've studied MPC or read about it. If you're trying to figure out if two secret satellites are going to run into each other, you kind of have to be accurate about that. So adding noise doesn't really work very well. Also in healthcare applications, if you're predicting dosing of a medication, you need to be pretty precise. And in financial applications like fraud detection, if you're looking at something that's 1 in a million or 1 in 10 million transactions that are fraudulent, you have to maintain precision. So it's this question of balancing utility and privacy, which always comes up. So the reason I say hybrid PETs is because we, after doing this for like 8 years, and really starting in the world of MPC and having an open source FHE library that we developed, most of our customers have very hybrid workflows. And depending on the use case, deployment, countries, regions, we see them as connected rather than separate. So, a lot of times talks are about FHE or MPC. It's always or, and I think it's a both and. And remember, it all starts in plain text at some point, and it has to be decrypted at some point. So our view of the world is very much hybrid scenarios. So again, that's how we're looking at input versus output privacy. When we're working on applications when there's billions of samples, adding noise wasn't really a need because re-identification was very difficult to do. But as we started getting into clinical trials for rare diseases, you have a very small sample size, that became a big issue, obviously. So just kind of a general overview, and this is kind of borrowed from Nigel Smart, which I'm sure many of you know him, Hawaiian shirt, smart guy. Just kind of looking at PETs of those that are secured mathematically, cryptographically, like MPC, FHE, where you can do functions like PSI or private information retrieval. And I put FL in here in secure aggregation as separate from federated learning, because if the model service provider, the global model, sees the gradients over time, obviously it's subject to inversion attacks. So federated learning then is this statistical method for securing data. And then of course TEs, which have really developed a lot in the last 2 to 3 years, especially with NVIDIA launching the H100s with CC mode. So we're seeing a lot more applications here of using all these different techniques depending on what the customer's needs are. And it is good to see organizations, governments, private organizations, industry groups getting together and trying to give recommendations. Unless you guys know something I don't, there's nothing highly quantifiable or specific yet. NIST has probably done the best job of giving high-level overview and recommendations around privacy budget. How do you estimate it? How do you calculate it? How do you monitor it? But obviously it's a big topic. IAB Tech Lab is probably furthest along, I think, in getting to some kind of industry standard measure of how we calculate privacy budgets. So just looking at some examples of how certain pets, not all pets, don't protect output privacy, right? So for a very simple example, if you have one result, which is x plus y, another result, which is x minus y, it's pretty easy to reconstruct the input data, right? Obviously, you get into machine learning and the complexity of the algorithms, distribution of the data, it gets harder to be able to infer the results. But the membership inference attacks, which Damien spoke about earlier, to determine whether a specific data point or individual was in part of the training data set when using ML, analyzing the output confidence scores and probabilities, you can, over time, infer the original data set, right? The model inversion attacks I talked about in FL. So for service providers who are hosting the global model, as all those local models send their gradients over time, they're going to be able to re-identify all that input data. Think about all the devices that we're using. I know many of you guys probably work for those device manufacturers, so make sure you are doing secure aggregation with some encryption in use method. So DP, again, I think about a third of the audience here is using it or developing it. So, the goal is that the output does not reveal whether an individual or specific data point was in the database, and you're adding noise. So what we are seeing is that add noise at the end, keep the data encrypted for as long as you can to maintain precision, and then, as we'll talk about in the privacy budget estimation, you can determine how much noise you need to add, if any. But if you add noise in the input data set, you can't get it back. You can't get the precision back at the end, right? So, obvious challenges, more noise, better privacy, but degrades utility. Again, going back to that fraud detection scenario, we did try adding even a very small epsilon, and the fraud model accuracy went down like 15-20% with epsilon of 1. So, in a lot of use cases is not sufficient. And also being able to prevent and avoid running infinite queries on a single or multiple data sets. So how much information is allowed to be revealed across all queries, computations, and especially in distributed scenarios where there's multiple parties contributing data. So privacy budget obviously was introduced, in '89? Sarah, you probably know this better than anyone, was Cynthia's paper. And has been developed there in the context of DP. Again, here we're looking at this as how do we apply these concepts and quantify it and apply it when using hybrid workflows, right? If I'm doing multi-party computation to train a model and I'm using FHE to run inference on a model, how do we apply the same concepts to that output privacy? So first you have the privacy budget allocation, which is how much budget do we have? And this is highly dependent on the privacy risk, how sensitive is the data, what is the dimension and the size of the data, how many parties are involved. You could have one party, for example, we're doing a lot of work in the EU in healthcare on like Alzheimer's prediction. And some of the research institutions have tons of data, but maybe one clinic only has a small set of data. So you have to think about the global privacy budget and the local privacy budget in multi-party scenarios. And then for monitoring, so this is for the service provider, like for example, an Inpher or some of your companies, if you're providing this service to your customers, that you have to estimate before running the computation. Obviously, if you run the compute, it's too late. You've already consumed the privacy budget. So how do you accurately estimate how much budget is needed for a given computation? And we do this, proactively. That's a proactive versus reactive that you see in privacy by design principles, where we will compile the function and give an estimate based on the dimensions of the data and the number of parties involved as to how much of that budget is going to be consumed by that function that you're running. And then after you run the computation, now you need to subtract from the privacy budget that you've allocated, right? And that is dynamic depending on the data itself. A lot of these databases, if you're updating frequently, that will increase your privacy budget. So it's not only about a static consumption of the budget, but how does the budget change as the data changes itself. And then you also have to take into consideration, the number of queries. If you run the same query, 5 minutes left, or I'm 5 minutes in? Okay, 5 minutes to speak. Perfect. It depends on the function that you're running. And so if you're doing chained operations, obviously that becomes more complex, and how do you predict and allocate the right privacy budget? So, privacy utility trade-off here, I think, again, NIST came out with recommendations, and the most specific they got was conservative, robust, and meaningful. So you can interpret that as you want, but meaning it is really use case dependent and data dependent, and also doesn't take into account necessarily the correlation between different variables and functions that you're running, right? So you can do query restrictions, just limit the number of queries and have each data owner say you can run these functions this number of times in this time period. Number of output bits. The thing is, with output bits, oftentimes becomes a bit restrictive because it is not taking into account, for example, if you have 6 bits and you have 50 decimal points, it doesn't take into account that if the correlating data point has a significant bit, it's only 1 bit of data loss, not 6 bits. And I'll go through a quick example of that. Also, entropy, k-anonymity, we won't get into today. But I'm going to run through this quickly, and I will say, unfortunately, the historical examples are gender-based, and we need another variable in there for non-gender-based, which helps to increase privacy budget. So we're just going by what are kind of known examples. So I know this text is small, but let me go through this basically. Being able to do a query restriction, limit to 3 queries, and in this scenario with the 2x3 column that you're seeing with 7 bits, you can run 3 queries and your privacy budget is still good. Here, whenever you're calculating by output bits, you can do the column average and you can do an average, but you can't do the copy average, right? That will deplete your privacy budget. Now, what's interesting then, if you look at the size input as used for your estimate, you can run the copy average, but you can't run the average, right? So these are the trade-offs that you look at of how you calculate and estimate privacy budget. So here I'm just going to summarize. I think you guys know privacy by design principles, so I won't go over that again. But I think the important part here is how you talk to customers and users. I was at the IEPP conference, which is mostly lawyers and privacy officers. And I asked the audience of like 400 people, how many data scientists are here? 2 raised their hand. So how many legal, security, CPO data officers are here today? Like 4. Okay, that's good. So there's like maybe 5 or 6 in the audience that raise their hand, but that's the problem, is how do we talk to our customers and our users? And executives and board members understand budgets. They deal with it every day, right? So if you talk in terms that they know, then it helps you to connect the dots, because I often find that the legal risk compliance side is very separated from this audience here. So quick conclusion, pets in general need to take into consideration privacy budget. We need to have a flexible means of doing this, and we are working on a dynamic calculator for privacy budget and calculation. If you want to learn more, there's a white paper, and we have a web talk if you guys would like to hear the experts talk about it, not myself. And obviously ongoing challenges. It's not solved. We've made great strides in it, but definitely need a lot more empirical evidence, like Damien talked about, to help fine-tune these models. And then I'll conclude and say, if you guys want to try out secure AI and don't want to give OpenAI all your data, check it out. It keeps it encrypted. You can also do RAG, so you can upload documents. And then XOR platform, which is doing hybrid pets workflows. And I also have to give a plug for the NPC Alliance. I know there's many members here, Google, Microsoft, but if anybody else, startup or individual, wants to join, let me know. We've got like 70 industry groups in there now, so, and it's a non-for-profit. So we're putting all the money back into development and standards. Cool. So that was at 1, right on time.
Yeah, we got time for questions. Chris, around.
Thank you.